Guys, Mr. Gucci here for part 2, numbers 10 until whenever I get tired, okay? So, from numbers 6, 7, 8, 9, I gave you the labels for each of these sub-levels, okay? For numbers 10, 11, 12, and 13, I do not give you those labels. You have to fill them in yourself. It's not a big deal. It's just the same as above. I'm just getting used to this process, okay? So let's figure out the electron configuration of potassium. Okay, so go in here, take a look. Potassium is element K. It has 19 electrons. So potassium is element K. All right, it has 19 electrons. Now, what's the order here? What's the Aufbau order? Well, I can go and look at the Aufbau diagram above, and I see it goes 1s, 2s, 2p. Did I mess this up? Let's hear 1s, 2s, 2p, 3s. Oh, yeah, I skipped the 3s. 3s, 3p. Well, that's embarrassing, but I fixed it. Yay. Okay, so the order is 1s, 2s, 2p, 3s, 3p. So I'm going to fill this in right down here. Okay, you can also just scroll up above and see what's written right above. It's pretty much the same thing. All right, so here we go. So 1s, we got 1, 2. All right. 2s, 3, 4. 2p, 7, 8, 9, 10. All right. 3s, 11, 12. 3p, 13, 14, 15, 16, 17, 18. And this next one is 4s. 4s. Now, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. This is the electron configuration for potassium. Okay, there we go. So same thing essentially, we just had to fill in the sub-level labels ourselves. In fact, I'm just going to go through, I'm going to do it here. So this is the 1s, this is the 2s, this is the 2p, right? It's a p because it holds 2, 4, 6 electrons. 3s, all right, 3p. You know this is going to be a p because it holds 2, 4, 6 electrons. All right, 4s, 3d. This is the first time that we get things that are slightly out of order. 3d, and then 4p. All right, let's see here. So boron. Boron. What's the configuration of boron? Well, boron is, boom, element 5. Boron. Well, that's actually real easy. I wrote in too many things here, all right? So 5 electrons, so 1, 2, 3, 4, 5. And so the rest of this was just unnecessary, okay? Unnecessary. Maybe you fill in the electrons first, and then you label them. I don't know, whatever works for you. So there we go. That's boron. On to chromium, which I happen to know is element Cr. All right, chromium is, bam, element number 24. This is a bigger one. This is a bigger one. So here we go. Element number 24. Well, this is 1s. 1, 2. 2s, 3, 4. 2p, 1, 2, 3, 4, 5, 6. 3s. So we're up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're up to 12 at this point. Maybe I'll write in here 12. All right. 3s, 3p, 13, 14, 15, 16, 17, 18. All right. 4s, 19, 20. 3d, 21, 22, 23, 24. Okay, so this is it. This is the electron configuration for chromium. Now, an important note here, I just want to remind you, you might be doing up, down, up, down, up, down. That'll make you lazy, all right? Because then you'll get to here and you'll be like, up, down, up, down. Guys, pretend this is a bathroom with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 urinals, okay? If you're going to go to the bathroom in one of these urinals over here, okay, it would be like super freaking weird if someone just like stood next to you with 8 perfectly free available urinals on the right, okay? Or perhaps it's a bus and there's like a row with like 5 pairs of seats and you have your own row and then someone sits next to you and there's a whole bunch of empty rows. I'm moving. I don't care if it seems rude, okay? I got a 4-hour bus trip to New York. All right, I'm not sitting next to some weirdo who smells like cabbage who wants to talk about the deep state for 4 hours, okay? Get your own damn seat, all right? So 1, 2, 3, 4, okay? Everyone gets their own seat. You do not double up unless you have to. Unless you have to, okay? That is called Hund's rule. Hund's rule. You don't double up in an orbital unless you have to. You don't put 2 arrows in the same box unless every box in that sublevel already has an arrow, okay? Continuing onward. Number 13 is arsenic. So let's find arsenic. All right, arsenic is element AS because it's poison and will kill your ass. All right, AS. Let's figure out how many electrons arsenic has. Boom! Ooh, 33 electrons. Arsenic has 33 electrons. Geez, I'm probably going to have to fill this thing out. So let's see here. 1s, 2s, 2p. Oopsie, I was getting lazy. All right, 3s, 3p, 4s. At a certain point, you just want to stop and be like, how many have I placed exactly? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, I placed 20 here, which means I got to place 13 more. Geez. All right, here we go. 3D. All right, 1, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. This is the 4p, by the way. Okay, all right. That's the electron configuration for arsenic. All right, that's quite a bit. Now, so there we go, guys. Okay, so the first step is look this element up on the periodic table to figure out its number of electrons, okay? From periodic table, whether from your book or on your phone or wherever you get the periodic table from, the link that I provided, great. Okay, then you place these electrons in the Aufbau order, filling in each sublevel at a time. And when you're filling up a sublevel, do an arrow for each box before going back and doubling up and doing a down arrow in each box. Okay, there we go. Now on to this next one. So these are not as hard as it seems, okay? In these ones, I give you an electron configuration. All right, I give you an electron configuration. And what I want from you is just tell me what element it is. What element? Assuming that it is neutral. All right, assuming that you got the same protons as neutrons. So let's take a look here. All right, we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 electrons here. And so on the periodic table, element 13 is aluminum. Element 13 is aluminum. So this is the configuration for a neutral aluminum atom. Okay? All right. Mr. Gucci, what about an ion that has 13 electrons? Yeah, it could be, but we're assuming that it's neutral. Okay, we assume that it's neutral here to make things a little bit easier for us. All right. If I had said this was the configuration of a +2 ion, it'd be a little bit trickier. All right, but here we go. Next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 electrons. If I go to the periodic table, element 22 is titanium. So this is titanium. Ain't so bad. This is probably the easiest problem on this worksheet. Okay? Lastly, the last set of problems. I give you an orbital electron configuration. Rewrite them as the written electron configuration. So if I don't get to these notes on the first day, guys, I think it's entirely possible that you can do this on your own. And let this be the instruction that shows you how. Okay, I'm going to change some numbers here, all right, to protect the innocent. All right, here we go. Let's see here. So I'm going to change this. Let's turn this into a 5. Okay, let's turn this into... Don't mind me. I don't know how to pause this video, so you just got to sit through it while I mess around with this for a little bit. Sorry, not sorry. I just want a nice magenta. Here we go. All right, cool. All right, guys, so here's how written electron configuration works, okay? I don't know if I'm going to put this on your homework yet, okay? I don't know if I'm going to put this on there, all right? But I think maybe you could figure it out, okay? But in any case, this video exists, and now you know what? I'm going to make this a new video. This is going to be a new video, all right? So I'm going to ignore this, all right? Stop it. This video is done. It is over. Done, okay?